I don't want to spend too much time on theoretical information, but to understand the packets sent to the destination systems and the reply packets as well, we should talk about the TCP/IP Internet Protocol Suite. OSI, Open Systems Interconnection, is a reference model for how applications can communicate over a network. A reference model is a conceptual framework for understanding relationships. The purpose of the OSI reference model is to guide vendors and developers so that the digital communication products and software programs they create will interoperate and to facilitate clear comparisons among communications tools. Most vendors involved in the telecommunications make an attempt to describe their products and services in relation to the OSI model. And although useful for guiding discussion and evaluation, OSI is rarely actually implemented, as few network products or standard tools keep all related functions together in well-defined layers as related to the model. Developed by representatives of major computer and telecommunication companies beginning in 1983, OSI was originally intended to be a detailed specification of actual interfaces. Instead, the committee decided to establish a common reference model for which others could then develop detailed interfaces, which in turn could become standards. OSI was officially adopted as the international standard by the International Organization of Standards, ISO. So what about the OSI layers? The main concept of OSI is that the process of communication between two endpoints in a telecommunication network can be divided into 7 distinct groups of related functions, or layers. Each communicating user or program is at a computer that can provide those 7 layers of function. So, in a given message between users, there will be a flow of data down through the layers in the source computer, across the network, and then up through the layers in the receiving computer. The 7 layers of function are provided by a combination of applications, operating systems, network card device drivers, and networking hardware that enable a system to put a signal on a network cable or out over Wi-Fi or any other wireless protocol. The 7 open systems interconnection layers are: Layer 7, the application layer. This is a layer at which communication partners are identified. Is there someone to talk to? Network capacity is assessed. Will the network let me talk to them right now? And it creates a thing to send or opens the thing received. Please note that this layer is not the application itself. It is the set of services an application should be able to make use of directly, although some applications may perform application layer functions. Layer 6, the presentation layer. This layer is usually part of an operating system and converts incoming and outgoing data from one presentation format to another. For example, from clear text to encrypted text at one end and back to clear text at the other. Layer 5, the session layer. This layer sets up, coordinates, and terminates conversations. Services include authentication and reconnection after an interruption. On the Internet, Transmission Control Protocol, TCP, and User Datagram Protocol, UDP, provide these services for most applications. Layer 4, the transport layer. This layer manages packetization of data, then the delivery of the packets, including checking for errors in the data once it arrives. On the Internet, TCP and UDP provide these services for most applications as well. Layer 3, the network layer. This layer handles the addressing and routing of the data, sending it in the right direction to the right destination on outgoing transmissions, and receiving incoming transmissions at the packet level. IP is the network layer for the Internet. Layer 2, the data link layer. This layer sets up links across the physical network, putting packets into network frames. This layer has 2 sublayers, the logical link control layer and the media access control layer. Ethernet is the main data link layer in use. Layer 1, the physical layer. This layer conveys the bit stream through the network at the electrical, optical, or radio level. It provides the hardware means of sending and receiving data on a carrier network. Let's see some of the most famous protocols of the layers. For ease of use, it's better to talk about physical layer and data link layer together. Here we have some protocols in data link layer and some physical media and connection methodologies in physical layer. Ethernet and 802.11 wireless LAN are the most known protocols of the data link layer. Ethernet is the name of the most commonly used network protocol that controls how data is transmitted over a LAN, which is a local area network. You need to have network interface cards in the devices that you want to connect to the network. A wireless local area network, WLAN, is a wireless computer network protocol that links two or more devices using wireless communication within a limited area such as a home, school, computer laboratory, or office building. This gives users the ability to move around with a local coverage area and yet still be connected to the network. Most modern WLANs are based on IEEE 802.11 standards and are marketed under the Wi-Fi brand name. IP, Internet Protocol, is responsible for addressing hosts, encapsulating data into transferred packets, and routing packets from a source host to a destination host across one or more IP networks. The best-known transport protocol is the Transmission Control Protocol, or TCP. It's used for connection-oriented transmissions, whereas the connectionless User Datagram Protocol, UDP, is used for simpler messaging transmissions. We're going to talk more in depth about these protocols in the next lecture. Again, for ease of use, the last three layers, session layer, presentation layer, and application layer, are thought of together as the application layer. Let me put another parenthesis here. We're talking about the OSI reference model here. In addition, there is another reference model called TCP/IP reference model. And instead of OSI model's last three layers, there is only a single application layer in the TCP/IP reference model. Just keep that in the back of your mind. And back to our subject. The application layer protocols are classified according to the protocol they are using in the transport layer. And these protocols interact with the end user via applications. Therefore, they are the most known protocols by just about everybody. Some of the most well-known TCP-based application layer protocols are HTTP, Hypertext Transfer Protocol, simply a communications protocol used to send and receive web pages and files on the Internet. Telnet is one of the simplest ways to exchange data between two computers. It allows two computers anywhere on a computer network, including the World Wide Internet, to exchange text and, other data in real time. FTP, File Transfer Protocol, is a communication protocol for the rapid, simple transmission of files across a network. SMTP, Simple Mail Transfer Protocol, is used to send and relay an email message between email servers. Note that it is not used to retrieve email messages from a server. Instead, either IMAP or POP is used to retrieve email messages. DNS, the Domain Name System, is a system used to convert a computer's host name into an IP address on the Internet. For example, if a computer needs to communicate with a web server nhs.uk, your computer needs the IP address of the web server nhs.uk. It is the job of the DNS to convert the host name to the IP address of the web server. The DNS uses both the UDP and TCP. SNMP, Simple Network Management Protocol, is used in network management systems to monitor status of devices and also spot problems.